doing section 6.2. Talks about solving quadratic equations by graphing. Just a few terms that we need to kind of go over, and then we'll kind of do a few examples. Shouldn't take too long. So, roots. That's when you solve an equation. That's when you take a factor and you set it equal to 0, and then you find the root of an equation. Zeros is when you take the related function and you find where the graph or the function crosses the x-axis. Roots and zeros terms are very similar. Just roots, I guess I always say roots goes with equations, and then zeros go with the related function. Very similar terms, I guess, kind of mean the same thing. When we solve a quadratic equation, there's actually three things that can happen. You can have one real solution, have a situation to whereas your parabola just touches the x-axis, and so therefore we actually call that a double root, but it only touches the x-axis in one place, so you're only going to have one solution. All right. So that kind of goes with this scenario. Two real solutions is kind of the obvious case where your parabola crosses in two different places. So you notice that the graph crosses the x-axis here and here. So you're going to have two solutions. All right. And then the situation to whereas you have no solution, and that means your parabola would, it could, I suppose it could open downward. In any of these cases, your parabola can open downward. But notice that this scenario, your parabola opens downward, but it doesn't even touch or cross the x-axis at all. So you're not going to have any solutions at all when you go to solve, those particular situations. So if you graph a quadratic equation and one of these scenarios comes up, then you should know how many solutions you should come up with. All right. So again, remember that this scenario here, we'll kind of get into this maybe later on. This is usually called a double root because that value would happen twice, and we'll explain that later on as we get to that part of it. So we're going to do a couple examples, kind of one of each of this, and then we'll see how it goes. My first example here, I kind of jumped ahead a little bit. I have x squared minus 3x minus 4 equals 0. My goal is to solve or to find the x values that makes that equation true. And I want to do this by graphing it. Eventually we'll just kind of get into the point where we're either using our computers on the grapher or using our graphing calculator, but we also should have a good idea on how to do it by hand too. So remember, to find the x value of your vertex, it's minus b over 2a. I take that value, I put it in my table. I plug 3 halves. I plug that x value into my function to find my output value. So right there is my vertex of my parabola. And then I'm just going to take, this is 1.5. So I'm going to go down, or I'm going to go to the left, I guess. I'm going to go backwards. I'm going to go 1, 0, and -1. I'm going to take those 3 values and plug them into my function, and then figure out half of my parabola, and then use the symmetry property to graph the other half. So when I plug 1 in, I get 1 minus 3, which is -2. Minus 4 is -6. I plug 0 in, I get -4. I plug -1 in, I'm going to get 1 minus a -3, so that's 4. That's going to be 0. All right, so now I'm going to sketch it. Okay, I say that my vertex is 3 halves, so 1.5, 6, 6 1/4. So it would be about right in here. So that's my vertex. I go to 1, -6. That's kind of just barely right above it. Real close. And then I go to 0, -4. And I go to -1, 0. So I see this. This is just my left side of my parabola. Now if I use the symmetry property, graphing this, I should be able to find my other points on this side. So for example, this is a half a unit, and then 2 units, so half and then 2. So my other point, being symmetric away from this one, should be right there. This is a unit and a half, so I should be right here. And the same thing goes for this one. So just by using my symmetric property, I should be able to graph the other half of it. And I guess that's this kind of review from yesterday. But my goal for today is to figure out at what points or to solve this. And when I do it by graphing, what I'm looking for is at these points, where does it cross the x-axis at? In this particular case, it crosses at x equals -1 and x equals 1, 2, 3, 4. So those right there are my solutions to that equation right there. And then I'm done. And that's what I'm looking for. I'm looking for those solutions that make this equation true. And that's when I graph it, it's wherever the graph crosses the x-axis are my solutions. Alright? Let's just do one more and then we'll be done. Here's one more problem we're going to do. I'm not going to tell you the third, there's 3 scenarios that can happen, and obviously we're only going to do 2 of them. So here's one of the other 2 that's going to possibly happen. Let's see if you can't kind of figure it out as we go along here. Kind of already started a little bit. I found my vertex. I have, the x value is 2, comma 1. So again, I'll probably just go to the left, find my left half of my U-shaped graph, or the left half of my parabola. So probably what I'll do is I'll just start with 1, 0, and -1, and plug those values in, and then then go ahead and graph it, and use my symmetry property. Graph the rest of it. So when I plug 1 in, I get 1 minus 4 is -3, plus 5 is 2, 0, I get plus 5, -1, I get 1, plus 5, I get 10 there. So let's see what happens here. So I get my vertex is at 2, 1. I have a point here at 1, 2. I have a point at 0, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 0, 5. So that's it. And then negative. Well, look, that point's clear up here. Well, I could actually stop right now and understand or answer my question. Because I know that this graph is my parabola should go up like this, or this half of it, and knowing that that it's symmetric, I have my other points over here as well. You notice that the graph doesn't even cross the x-axis. So if you can kind of pay attention and look ahead a little bit, you notice that this parabola or this equation right here is not going to have. There has no solutions to it, or no real solutions, should I say. No real solutions. Alright? No real solutions to that one. So that's a good example of that one. I want to put some try this problems up here, and then we'll be done. Quick picture of the 2 try this problems I want you to try. Solve by graphing them. Okay? This one right here, I threw a little curveball at you. Remember what the negative sign means of this coefficient here. What happens to your parabola? And then down here, another curveball where the equal sign You know, obviously you just got to kind of do something simple there, and put it in the form of, you know, a quadratic equation, make it equal to 0, and then go from there, and then solve that. Okay, solve by graphing. All right, good luck.